Hi learners! In today's video, you will learn how to apply trigonometry in solving a real-life problem. The video will demonstrate how trigonometry is used in determining the horizontal distance between structures or objects. It shows how the angle of elevation or the angle of depression is used so that you will be able to apply these learnings in answering application problems on that topic. Strategies in analyzing and solving a problem related to the topic together with how the calculator is used in getting the answer are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on trigonometric ratios, or if you have an assignment on this topic, or if you are preparing for a test in math, or test in geometry in particular, or you're someone who's interested in learning math, then this video is for you. Recall that trigonometry is a branch of mathematics that deals with the connections between the measures of the sides and angles in a right triangle. These connections are expressed in the following trigonometric ratios. Sine A equals opposite side over hypotenuse. Cosine A equals adjacent side over the hypotenuse. Tangent A equals opposite side over the adjacent side, where angle A is the reference angle as shown in the figure. For the detailed discussion on how to label the sides of a right triangle, watch the video on trigonometric ratios. The link is down below. In real life, the reference angle is oftentimes referred to as the angle of elevation or the angle of depression. The angle of elevation is an angle created when an observer, represented by the eye in the figure, is looking up at an object above the horizontal as shown. As the observer looks up at the object, it creates an imaginary line between the eye and the object. This is the line of sight. The space between the line of sight and the horizontal with the observer's eye is the point where these two lines intersect is the angle of elevation. The angle of depression, on the other hand, is the angle created when an observer is situated above and is looking down at an object on the lower level. This angle is between the horizontal and the observer's line of sight as shown in the figure. Always remember that the angle of depression is not the angle between the line of sight and the vertical. Look at the figure, learners, so you will not make this mistake. Let us look at this simple problem so you will learn how to apply trigonometry in solving this real-life problem. Here's the problem. An observer at the top of the building sights a car below as shown with an angle of depression of 40 degrees. If the building is 80 feet tall, how far is the car from the base of the building? Write your answer to the nearest tenth. A figure is given. Here are the options. Option A, 61.3 feet. Option B, 67.1 feet. Option C, 95.3 feet. Option D, 104.4 feet. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You're right, we are to find the distance from the car to the base of the building. What are given? We're given a figure, an angle of depression of 40 degrees, and the height of the building, which is 80 feet. Now we will modify and put in place what are given in the problem that are not reflected yet on the figure. Let us go over the problem again. It says, an observer at the top of the building sights a car below as shown with an angle of depression of 40 degrees. On this sentence, everything is on the figure except for the angle of depression. We will put this on the figure. By the way, where are we going to put the angle of depression, learners? Okay, so perfect, we put it here. Then the problem says if the building is 80 feet tall, so we label the height of the building, which is 80 feet. Next, it says how far is the car from the base of the building? For this, we put an X on the part of the triangle representing this distance, the distance between the base of the building and the car. Okay, next, we assume that the angle between the ground and the building is 90 degrees. So we will put a box indicating that we have a 90-degree angle on the figure. Now look at the figure, learners. We have a right triangle with the building, the ground, and the line of sight as its sides. Can we now use this triangle to solve for x? Okay, so no, not yet. For us to be able to make use of this triangle, one acute angle must be known. As of now, we do not know the measure of any acute angle inside the triangle. Take note that the angle of depression of 40 degrees is outside of this triangle. Look at the figure closely, learners. Do you see what I see? The horizontal and the ground are parallel. Now, between these parallel lines is a transversal, the line of sight. Do you see these, learners? Since the lines are parallel, the alternate interior angles that are created with the transversal are congruent. Do you agree? Hence, the angle below is also 40 degrees. We can now use this triangle in solving the problem with this angle, the 40-degree angle below, as the reference angle. Now, for us to be able to apply the trigonometric ratios in solving the problem, we need to label the hypotenuse, the opposite side, and the adjacent side of the triangle. We will start by labeling the hypotenuse, the longest side. Next, we label the side across the reference angle, the opposite side. And finally, the side that is not labeled yet, the adjacent side. Look at the labeled triangle this time, learners. Which sides have corresponding values? Okay, so the adjacent side, for it has x, and the opposite side, for it has a measure of 80 feet. The hypotenuse has no assigned value, so it is not needed in solving this problem. We will put an x on that side. Now, of the three trigonometric ratios, which one has the opposite side and adjacent side on it? The tangent. So, we will use the tangent ratio. This is the trigonometric ratio that will help us solve the problem. Now, we start by writing the ratio. So, tangent A is equal to opposite side over the adjacent side. Look at our drawing, learners. Now, we plug in the values that are on our drawing into the equation. Angle A is 40 degrees, the opposite side is 80 feet, and the adjacent side is x, the distance that we are looking for. So, tangent 40 is equal to 80 over x. We can rewrite the equation this way. Tangent 40 over 1 is equal to 80 over x. Cross multiplication gives us x tangent 40 equals 80. Dividing both sides by tangent 40, we have x is equal to 80 over tangent 40. At this point, we have to use a calculator to solve for x. We will use the TI-84 calculator. So we turn the calculator on and set it to degree mode. To set to degree mode, hit mode. This is what you will see on the screen of your calculator. Now, scroll down by hitting the arrow down to radian, then hit the right arrow to degree. This is now what you see on your calculator. With this on the screen, hit enter. Then clear the screen by hitting clear. The calculator is now ready for use. Again, the equation that we want to solve is x is equal to 80 over tangent 40. We now type what we see on the right side of the equation into our calculator, remembering that the bar is a division sign. We do not have to input degree, for the calculator is on degree mode already. Okay, so type 80, then hit the division sign, then hit tangent, and type 40. This is what you see on the screen of the calculator now. With this in the screen, hit enter. Bingo, we have the answer. Thus, x is equal to 95.3 feet. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned. We have learned that, first, trigonometry is a branch of mathematics that deals with the connection between the measures of the sides and the angles in a right triangle. Second, the ratios of the sides of a right triangle in relation to its acute angle are called trigonometric ratios. Third, the following are the trigonometric ratios of triangle ABC with angle B as its reference angle. Sine B equals opposite side over the hypotenuse. Cosine B equals adjacent side over the hypotenuse. Tangent B equals opposite side over adjacent side. A figure is given. Fourth, the angle of elevation is the angle created when an observer is looking up at an object above the horizontal. This angle is between the observer's line of sight and the horizontal. Fifth, the angle of depression is the angle created when an observer is situated above and is looking down at an object on the lower level. This angle is between the horizontal and the observer's line of sight. Sixth, the alternate interior angles formed by two parallel lines in a transversal are congruent. This makes it possible to shift the reference angle, the angle of depression, from its original position to its alternate position, marked with a donut on the figure. Seventh, always set the calculator to degree mode before using it. Eighth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. Ninth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below. And do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye!